Okay, I wanted to do something a little bit different today, and what I wanted to do was actually try to approximate E with a spreadsheet. And I'm in here in Google Sheets, and as you can see, we have these two different, see if I can drag this, we have these two different definitions, or two different ways that we can use to calculate E. We get this top one, we have this top one we can use for E where it's the limit as n approaches infinity of 1 plus 1 over n to the n. And we have this other series definition where it's the infinite series of 1 over n factorial. If you're not familiar, the numeric approximate value for E is 2.71828, on and on. I got this from Wolfram Alpha, this approximation. So to start with, we'll look at this top. We'll try to use this top definition. We're going to just need some values. So first, the value we're going to need is we're just going to need 1, and we can start anywhere, I guess, but I don't think negative values are particularly helpful. So we'll start at 1, and we'll just look at integer values for this, and we'll just sum this up. Of course, we can't sum to infinity, but let's just look at a few values. We'll go to 32, let's say, and then we could go straight for the full answer, the full approximation of this. But what I want to do first is let's just see what 1 plus 1 over n is going to be. We'll just do this with a real easy formula. We'll do 1 plus 1 over this, and yes, I'll autofill it. And I realize I probably should make this larger so you can see it more easily. Or if I can zoom in. Okay, I think that looks better with me more zoomed in here. That's probably going to help. So again, we got our values here for 1 plus 1 over the n value, with n value in this column A here. And not too much to talk about here. They're all these values are going to be between like 1 and 2. But now let's get to the real thing we're looking for. We want to see what happens for 1 plus 1 over n to the n. We want to see how well is this going to approximate our value for E. So what I can do is just take this B value, and I can do it as an exponent. Take this value and raise it to the n value. Get a value. Yeah, let's autofill it. And as you can see, okay, we start at 2.25, 2.37. We're getting closer and closer to our decimal approximation over here, 2.718. But now the interesting thing is when you do this in a spreadsheet, it usually doesn't take this many iterations. Like typically when I do these, I think I did a video previously. I know I did one for Lambert W, and it only took maybe 5 or 6 approximations to get really close to the Lambert W value. And that's what you usually find, like if you use Newton's method or whatever approximation method. So this is actually not very good we're already to our 32nd iteration, and we're still we don't even have the first decimal place yet. Of course, we can push this further and get more values. So then let's see, we did 250. So if I do this all the way down to 251, we still only have 2 decimal places here, 2.712, whereas again, the value we want is 2.718. So I think the theme here is when you do your approximation using this formula right here, right? When we do our approximation using this value right here, it kind of works, but it just takes a lot of iterations. You might have to do this, maybe more than this spreadsheet will deal with, right? I could go to let's go to 1,000. I think you can add more rows, but even at 999, we're still only at 2.717. So this is not the best way to approximate, even though, you can see where it's going. It basically works, but it's just not great for approximating. So what I want to do instead is actually let's go back to this, what we have over here, and let's use this second method and do it as a sum, of 1 over n factorial. Okay, so now I've started another sheet, and I've just copied over a bunch of n values. This is really the same thing we had on the previous one, but now let's approximate. I think before we approximate the whole thing, let's just get our values for n factorial. Let's see if I have okay, so we have a factorial function, and we just want the factorial of this n value. And yes, I've got some large values in here, but anyway, you can see our factorial values in this column B. Actually, before we get the whole thing, let's just do 1 over n factorial and see what that looks like. You just want the value for 1 over divided by this. Interesting, those are going off to 0 pretty fast because you got these big factorial numbers. This isn't really 0, right? This is really saying it's a very small number. And then in column D, this will be our estimate for E. So we'll start, I think if you just notice back to this definition, we have this n equals 0 value. So there's an extra 1 that's going to be in our sum that we're not including in this table. So for my starting value to get 2, I'll just do 1 plus this right here. And let's not accept that. And then okay, so for our second iteration, we'll add 2, because we need to just sum up all these n factorials. So it's going to be the number above plus this to get our current sum. So that's good. We're getting closer. We know our E is 2.718. So we went from 2 to 2.5. We do it again. We're at 2.66. We do it again. 2.708. Look at how much faster it's converging than the other one, right? It took a long. We go back to the other one. Yeah, it wasn't. We're this is at 100. So going on, let's see if we do some more of these. So okay, we've already basically done as well as we were at 999 rows. Right, let's see. Here we were at 999. That was 2.716. And then we've got the same accuracy here when n is 5. This is just so much better for approximating. So we can go on and do some more, but you'll see that it doesn't take very long to get a pretty good approximation. Right here, 2.71828. Actually, okay, 2.718281801. This here is 2.718281882. So it's here we already have 7 decimal places. So I think you can see where I'm going with it. Over here, this second way is going to be the much faster way, much less iterations. I mean, not to say this gives you some idea, but if you want any kind of accuracy, this is going to be the better way. But one other thing I thought we could do before finishing up is just going back to this first way. Let's just look at a graph of this. Okay, so looking at our graph over here, just focusing on the positive values. We don't care about the negative values. It might be helpful. It would be good if we could get a value for E on here. I wonder if I can do y equal to E. Okay, that's great. So we have this blue line. This is going to be our E line. And so you can kind of see that it's not that good of an approximation in a way, because it starts, it's going to, obviously when you get big enough values, you're getting very close to this E value. But in if you look at a few iterations, at 4, 5, 6, 7, there's a very clear gap here. We're only at 2.5. And, eventually we get to 2.6. Of course, this is exactly what we found in the spreadsheet, so there's nothing new here. It's just kind of visually, you can just see very clearly that this red line is not quite this blue line, and it's not that great of an approximation when you have small x values or n values over here. So that's really all there is to it. I just thought it was interesting to do a approximation for E with a spreadsheet 2 different ways, and then also looking at the graph. So there you have it. That's it for today. Thanks everyone for watching. Have a good day.